Hi there, Mr. Sutton here, bringing you the IM372 Extra Practice Number 2 solutions on special right triangles. For this triangle, I want to find the values of A and B. Now, since this is a right triangle and they only gave me one side, I can't use Pythagorean theorem. So let me see if this is at least a special right triangle. We've got 60 degrees over here. That means there's 30 degrees left for that other non-right angle. So this is a 30, 60, 90 triangle. So the sides then are in the ratio of s to s radical 3 to 2s. Let me go ahead and label each side of the triangle with one of these s expressions. So the 30 degree side over here that they actually gave us, that's the s side. The 60 degree side down here, b, that's s radical 3. And that means that a, the hypotenuse, must be 2s. So it looks like s equals 10 radical 3 over 3. They actually gave us that pretty much right off the bat. We just have to plug it in now to find the values of a and b. I'll go alphabetically. A is 2s, so that means a is 2 times 10 radical 3 over 3. So that's going to be then 20 radical 3 over 3. And it looks like b is s times radical 3, so that's going to be 10 radical 3 over 3, all of that times radical 3. Well, radical 3 times radical 3 is just 3. So that's going to cancel out the 3 downstairs, and that ends up just being 10. For this triangle, trying to find the missing sides given only one side, since it's a right triangle, and I already have 45 degrees here, that means this other angle is also 45. So I, in fact, have a 45, 45, 90 right triangle, which means the sides are in the ratio of s to s radical 2. Labeling those sides on my triangle, the s sides are going to be across from the 45 degrees. So we have an s side over here and down here as well. And the hypotenuse then is going to be the s radical 2 side. So I see that one of those s sides happens to have a value of 3. So I can write that s actually equals 3. And now that I have the value of s, I can find the other sides. So let me just go alphabetically. X, it looks like, is equivalent to s radical 2. So that means that x equals 3 radical 2. And y is the other s side. So that means that y equals 3. On this problem, we have a right triangle, but only one side is given, and I want to find the other sides. So let me see if this is a special right triangle, because I can't use Pythagorean theorem. I've got 60 degrees here. 90 minus 60 gives me 30 for this other angle. So this is a 30, 60, 90 triangle, which means the sides are in the ratio of s to s radical 3 to 2s. Let me label the triangle with those s expressions. So I've got my s side across from the 30 degree side right over here. And then across from 60 degrees, that's the s radical 3 side. And then finally, the hypotenuse is going to be my 2s. So it looks like, let's see here, the only constant they gave me was this 6 radical 3. That's equivalent to s radical 3. So I can write s root 3 equals 6 radical 3. And now if I divide by radical 3, I can solve for s. So those basically cancel and leave me with just s equals 6. Now that I have the value of s, I can go back and plug that in to find the a and b values. So for a, that's equivalent to 2s, which means a is 2 times 6, so a is 12. And then for b, that's equivalent to just s, which means b equals 6. The first thing I noticed trying to find missing sides on this right triangle is that the non-right angle is 60 degrees, which means this other angle is 30 degrees. So that means we have a 30, 60, 90 right triangle. And the ratio of sides for that triangle is going to be s radical 3, and 2s. So let me just go ahead and label each side of this triangle with one of these s's. So the side opposite from 30, that's going to be our s. Opposite from 60 over here, that's the s root 3. And the hypotenuse here, that's our 2s. So taking a look at the side that they actually gave us a constant for, that's this 10 over here, we see that s radical 3 equals 10. So let's go ahead and solve for s, and that'll give us the other two sides. So to solve for s, I have to divide by radical 3. And I am going to have to put my answer in simplest radical form at some point anyway. So let me go ahead and simplify this radical now, or else I'll have to do it later anyway. So if I multiply by root 3 over itself, this becomes 10 radical 3 over just regular 3. So there's our value for s. Now, taking a look at our variables, it looks like x equals s, which means that x equals this 10 radical 3 over 3. And it looks like y equals 2s, which means that y is going to be 2 times this 10 radical 3 over 3, which is going to be 20 radical 3 over 3. On this problem, trying to find these missing sides of a right triangle with one side given, let me see what this other angle is and see if this is a special triangle, because I can't use Pythagorean theorem. So if I've used up 45 here, there's 90 minus 45, or 45, left over for that other angle. So this is a 45, 45, 90 triangle. The sides then are in the ratio of s to s radical 2. Labeling those on my triangle, across from these 45 sides I've got my s's, so s over here, and this side here is also an s. And then down here, across from 90 degrees, that's my s radical 2 side. Now, the only constant they gave me for a side was this 4 radical 2, and we see that that's equivalent to s radical 2, so I can write s root 2 equals 4 radical 2. Dividing by radical 2 to get s by itself, I see that s just equals 4. So now that I have the value of s, let me plug that in to get a and b. It looks like a and b, actually, they're equivalent to each other, and they both equal s. Let me write a and b down there. There we go. And as we said, those both equal s. So that means that a and b both have a value of 4. For this problem, trying to find my missing sides with only one side given in a right triangle. Since I can't use Pythagorean theorem with only one side, let me try special triangles. So if I got 60 degrees there, that means that 30 degrees is my other angle. So this is a 30, 60, 90 triangle. So our sides then are in the ratio of s to s radical 3 to 2s. Putting those on the triangle so I can tell which is which, across from 30, I've got my s side up here. Across from 60, that's my s radical 3 side over there. And here on the hypotenuse, across from 90, that's my 2s side. The only constant they gave us was this 14 radical 3 over 3, and that's equivalent to this 2s expression. So I can write 2s equals 14 root 3 over 3. And then if I divide both sides by 2 to get s by itself, basically 14 divided by 2 is going to give me 7 radical 3 over 3. So that's the value of s. Now that I have that, let me plug that back in to find x and y. We'll go alphabetically. X is going to be s times radical 3. So that's 7 root 3 over 3 times 3, radical 3 rather. And the radical 3 in the numerator and this radical 3, those get multiplied together to give me just 3. 3 cancels out with the 3 in the denominator, so that gives me just a value of 7. And now it looks like y is equivalent to s, so that means that y equals exactly 7 radical 3 over 3. To find x and y in this right triangle with only one side given, we're going to try special right triangles. Let's see what this other angle is here. 90 minus 60 gives me 30 over there, because we already had 90 used up by the right angle. So this turns out to be a 30, 60, 90 right triangle. So we know the sides then are in the ratio of s to s radical 3 to 2s. So if we can find the value of s, we can get all three sides. So let me label my triangle. 30 degrees, that's always across from the s side, so that side right there is s. And then 60 is always across from s radical 3. And then our hypotenuse down here is always 2s. So it looks like s is equivalent to 7 radical 3 over 3. We kind of got that one almost for free. But if I plug s in, that'll give me the other two sides. So it looks like s is equal to 2s. So that means x is going to be 2 times 7 root 3 over 3. So that's going to be 14 radical 3 over 3. And y is going to be s times the square root of 3. So that's going to be 7 radical 3 over 3 times radical 3. Well, radical 3 times radical 3 is 3 in the numerator. That cancels the 3 in the denominator. So we're just left with the 7 that was also in the numerator. And there's x and y. For this problem, I notice that I've got a right angle and 30 degrees. That means there's going to be 90 minus 30, so 60 left over for that other angle. which means we have a 30, 60, 90 right triangle. That makes our lives a little bit easier. It means I only need to know one side to find the other two sides. So the ratio of sides is s, s radical 3, and 2s. Let's go ahead and label our triangle with those three ratios. So the s is going to be across from 30. Across from 60, we've got s radical 3 over here, and our hypotenuse across from the 90 degrees is our 2s. So let's look at what they actually gave us in terms of constants. The only constant we have is this 12 over here, and this goes with the s radical 3 side. So we can say s radical 3 equals 12, and if we solve for s, that should help us find the sides we're actually looking for. Okay, so let's just divide by 3. So we have 12 over radical 3. And let me take a moment to simplify this. So if I multiply by radical 3 over itself, I've got 12 radical 3 over just 3, which I can reduce to, let's see, 12 divided by 3, that gives me 4 radical 3. So that's the value of s. Now to find the value of the actual sides, let's look at x first. I'll just go alphabetically. X is equivalent to 2s, whatever s is. So that means x is equal to 2 times this 4 radical 3. So x then must equal 8 radical 3. Now for y up here, y is equivalent to s that we labeled it with. So if y equals s, then y just equals this 4 radical 3 that we found earlier.